So I was talking about the amplifier bandwidth, and I said that this peak in the intensity at the resonance frequency of this amplifier is just not a sharp peak, but it has some width. And if you just denote this width as delta f around this resonant frequency, and the resonant frequency is just if you have a three-level atom amplifier, and the transition between 3 and 2 is producing the amplifier frequency, then f0 is going to be just E3 minus E2 divided by h. So we have a kind of bell-shaped curve peak around this resonant frequency f0, and I said there are three reasons of the amplifier, reasons for the width. Was the first, I said spontaneous emission, spontaneous emission, and the spontaneous emission we denote as delta fs is inversely related to the lifetime of the electrons that stays on the third level, and this lifetime is usually denoted by tau s. This is the as I said, I said this is going to be in the order of nanoseconds, in the order of 10 to minus 9 seconds, and this is typical for a electron spending time in the upper excited level. So longer the lifetime is going to be shorter this width of the bandwidth, and this is why, because we have this delta fs, which is the bandwidth caused by the spontaneous emission, is inversely related to the lifetime of the the electrons living on this third excited level, third energy level. So the second is collision. This is called collision, sometimes collision broadening. Okay. And as I said, the one cause of this bandwidth widening is because the atoms are collide, and the collision of the atoms will just make the energy levels to have some uncertainties around, right? So that's causing the widening of the line, and this is again inversely related to the collision lifetime. Okay, if an atom on average collides with the nearby atom every tau c seconds, so this is the amount of time that is spent by atom from one collision to other collision. Okay, and this contribution is just 1 over the inverse time of the collision time, 1 over the collision time. Alright, so the last one, as I said, was this Doppler shift, Doppler broadening, and I explained this, that this is because of the motion of the atoms in some direction. This is given by this expression, 2 times f0, the resonance frequency, multiplied by the average velocity of the atoms in the medium. This can be a gas of atoms, or even it can be, as I said, solid crystal atoms. Even for solids, the atoms will vibrate and will have some average velocities. This is about that. The average velocity divided by the speed of light, multiplied by the resonant frequency, and this is also multiplied by 2. So the last broadening will come from this expression. Okay.